Good morning, everyone. Let us start. Remember,
Good morning, sir.
we have been learning Chapter 4 Climate of your NCERT textbook, Geography textbook. We have learned about factors affecting India's climate. Today we shall discuss about the Indian monsoon. So I will present my screen. The Indian monsoon. So let us read this paragraph. The climate of India is strongly influenced by monsoon winds. The sailors who came to India in historic time were one of the first to have noticed the phenomenon of the monsoon. They benefited from the reversal of the wind system, as they came by sailing ships at the mercy of winds. The Arabs, who had also come to India as traders, named this seasonal reversal of the wind system monsoon. This we have learned earlier. The word monsoon is derived from the Arabic word mausim, which means season. But the definition of this monsoon is the seasonal reversal of the wind system. Seasonal reversal means change in the direction of wind with the change of the season. So this picture photograph shows the arrival of the monsoon, the onset of the monsoon. And now let us continue. Here the monsoons are experienced in the tropical area roughly between 20 degree north and 20 degree south. Okay, the monsoon wind systems are experienced in the tropical area roughly between 20 degree north and 20 degree south. So let us see a map. So roughly here in this area, in this region, the monsoon wind system experience. Okay, roughly 20 degree north to 20 degree south in east hemisphere. To understand the mechanism of monsoons, the following facts are important. To understand, to learn how the monsoon wind system work. Okay, the following facts are important. Now let us learn what are the facts. So the first one is the differential heating and cooling of land and water creates low pressure on the landmass of India, while the seas around experience comparatively high pressure. See, differential heating and cooling of land and water we know that land is opaque, okay, that sunlight cannot pass through, and that is why land is heated very quickly. whereas water, you know, this is transparent, and sunlight can pass through very easily. So let us see, this is the land surface, and here we have water body. You know, land surface is opaque, so here sunlight cannot pass through. It is absorbed a little, okay, here at the surface, only about 10-15 centimeters, okay, and but in the water it can be penetrated, okay, penetrated deep into the interior of the water body, and that is why the land surface is heated very quickly, and water bodies are, okay, heated slowly. Likewise, land surface is also cooled down very quickly, and the water bodies again cools down very slowly. And because of these differences, okay, here on the land we find this low pressure, then here we find high pressure. Okay, this is for the summer, and reverse is the case in the winter. So this fact is very important to understand the mechanism of monsoon. Okay, the differential heating and cooling of land water creates low pressure on the landmass of India, while seas around experience comparatively high pressure. See here, okay, here on the land, so in this winter, sorry, in summer there will be low pressure, okay, there will be low pressure here, and over the seas there will be high pressure. So this is due to differential heating and cooling of the land and water. Any question from your side? So this is the chapter climate, okay, the chapter climate. We are learning about the Indian monsoon, and page number 30, okay, page number 30. It was started from page number 28, now it is 30, okay. So we have learned that land surface heats up very quickly and cools down very quickly, whereas water bodies warms up slowly and cools down slowly. And that is why we find pressure difference between land and the sea, okay, we find pressure difference between land and the sea, say with the change of the season. In the summer season, we find low pressure over the land and high pressure over the seas. So the reverse is the case in the winter season. That is, in the winter season you will find high pressure over the land and low pressure over the sea. So this is because of the differential heating and the cooling of land and the water. Next we have another fact. The shape of the position of intertropical convergence zone in summer over Ganga plain So what do you mean by ITCZ, Intertropical Convergence Zone? So this we have to again recall the global pressure and the planetary wind system. See here along 30° north and the south we have subtropical high pressure cells. And along the equator we have equatorial trough of low pressure, and from the subtropical high pressure welcome back. Internet connection was lost, so let us continue. I will present my screen again. Okay, so here from the subtropical high pressure belt, this a wind known as trade wind is blowing towards equator. Okay, and the one that is blowing in northern hemisphere is known as northeast trade wind, and the one which is blowing in the southern hemisphere is known as southeast trade wind. So this zone along the equator, 5° north to 5° south, okay, of the equator, where the trade wind converges is known as ITCZ. Okay, ITCZ, that is Intertropical Convergence Zone, is the zone where northeast trade wind and the southeast trade winds converge, okay, together, meet together. And this ITCZ shifts with the change of the sun's position. Okay, see here this diagram. See, with the apparent movement of the sun, this ITCZ, which is formed along the equator, is shifted towards the north and lies over the Ganga plain in the summer season, that is in June, July, and whereas it is shifted to the south in the winter season. So this is because of the change of the sun's position, okay, with the apparent movement of the sun. The ITCZ moves towards the north and lies over the Ganga plain as mentioned here, okay. In summer, this ITCZ moves over the Ganga plain, and this ITCZ is also known as the monsoon trough during the monsoon season. So this is about ITCZ. Any question from your side about ITCZ? Do you have any question about ITCZ? Any question regarding ITCZ? Okay, let us continue. Next we have presence of high pressure area east of Madagascar. Okay, to start the onset of the monsoon, presence of high pressure area east of Madagascar Island, approximately at 20° south over the Indian Ocean, is required. The intensity and the position of the high pressure area affects the Indian monsoon. So that means there should be here, this is Madagascar Island, okay, and east of Madagascar Island there must be a high pressure system, and this is just east of the Madagascar, and the intensity of this high pressure system also affects the Indian this monsoon. Okay, here there must be high pressure east of the Madagascar Island. This is point number C. Then fourth, The Tibetan Plateau gets intensely heated during summer, which results strong vertical air currents and the formation of low pressure over the over the plateau at about 9 kilometers above the sea level. Actually, by April and May, the snow and the ice over the Tibetan plateau, okay, is melted, and that is why a very big intense low pressure is developed here. So this is in the month of this May. Okay, in the month of May and June, a very intense low pressure is developed over the Tibetan plateau. Okay, Tibetan plateau get intensely heated by the sunlight during summer. This is mainly in May and June, and because of this intense heating, this low pressure is developed over the Tibetan plateau. Next, we have the movement of the westerly jet stream to the north of the Himalayas and the presence of tropical easterly jet stream over Indian Peninsula during summer. So this is another condition, okay, to start the Indian monsoon. See here. See, here lies. This is for winter season. Okay, during the winter season, so let us say here lies the this Himalayan mountain. Okay, this is the Himalayan mountain, and during the winter season, the jet stream. So this arrow shows the westerly jet stream, and during the winter season, the jet stream flows south of the Himalayan mountain in this way. Okay, so these are the Himalayan mountains, and during winter this westerly jet stream flows south of the Himalayan mountain. But when the summer season sets in, this westerly jet stream is shifted north of the Himalayan mountain in this way. Okay, so this is the new position in summer. It is shifted north of the Himalayan mountain. Let us see another map. Okay, see here, and here lies the Himalayan mountain, and now the westerly jet stream is shifted north of the Himalayan mountain, and here we find this tropical easterly jet stream. So this condition is required for the onset of the monsoon. See here, in this case, so in summer, the jet stream is shifted north of the Himalayan mountain, and so a tropical easterly jet stream is present over the peninsular plateau India. See here, so this arrow shows tropical easterly jet stream. Okay, it's mentioned here. The movement of the westerly jet stream north of the Himalayas and presence of the tropical easterly jet stream over the Indian Peninsula during summer. So this is for the these are the conditions, okay, required for the starting of the Indian monsoon. Any question from your side? Any question? So let me tell you again, during the this summer season, okay, due to differential heating and cooling of land and water, we find low pressure over the northwestern part of India. Okay, due to intense heating of the land mass, we find low pressure over the northwestern part of India. At the same time, we find this high pressure over the Indian Ocean. This is one condition. Then in the beginning of this summer season, that is in the month of May and June, another very intense low pressure is developed over Tibetan Plateau. due to intense heating of the plateau. And here in the southern hemisphere, east of Madagascar island, a high pressure is developed. Okay, east of the Madagascar island, a high pressure is developed. And another condition is that during the summer season, this westerly jet stream, which was flowing south of the Himalayan mountain, has been shifted north of the Himalaya. Okay, then another condition is that here in the Peninsula Plateau, we find a tropical easterly jet stream. One jet stream is found here known as tropical easterly jet stream. And because of all these conditions, this wind known as southeast trade wind, is attracted towards Indian landmass. And when this southeast trade wind is attracted towards landmass, it is turned to the right due to the Coriolis force. It is turned to the right and it becomes southwesterly, and this wind is known as southwest monsoon. So in this way, the southwest monsoon wind system is started. Okay, so this is about the mechanism of the Indian monsoon. And so let me continue. So this intertropical convergence zone we have learned earlier. So one more condition about the Indian monsoon is that it has also been noticed that changes in the pressure conditions over the southern ocean also affect the monsoon. Changes in the pressure conditions over the southern ocean also affects Indian monsoon. Normally, when the tropical Eastern South Pacific Ocean experiences high pressure, the tropical Eastern Indian Ocean experiences low pressure. But in certain years, there is a reversal in the pressure conditions, and the Eastern Pacific has lower pressure in comparison to the Eastern Indian Ocean. This periodic change in pressure condition is known as Southern Oscillation or ESO. Okay, now let us see another diagram. See here, under the normal condition, okay, see this is this section. So this section, this is the southern hemisphere, okay, southern oceans. And under the normal condition, in this area, okay, so in this area we find high pressure. This is normal condition, it is mentioned here. Okay, normally, see here, normally when the tropical Eastern South Pacific Ocean experience high pressure, tropical Eastern Indian Ocean experiences a low pressure. Okay, see here, so this is the tropical Eastern Pacific Ocean, and see normally we find high pressure over here and low pressure over the tropical Eastern Indian Ocean. So this is tropical Eastern Indian Ocean. This is the normal condition. But in certain years, instead of this high pressure here, we find low pressure over the Eastern tropical the Southern Ocean, and we find high pressure over the Eastern tropical Indian Ocean. So this change in the pressure condition is known as Southern Oscillation. Okay, ESO is mentioned here. When the tropical Eastern South Pacific Ocean experiences high pressure, tropical Eastern Indian Ocean experiences low pressure. But in certain year there is reversal in the pressure condition. Okay, and this periodic change in the pressure is known as Southern Oscillation. So let me repeat. Normally we find high pressure over the Eastern tropical Southern Pacific Ocean. Okay, normally we find high pressure over the southern eastern tropical Pacific Ocean, whereas we find low pressure over the eastern Indian Ocean. But in certain years we find low pressure over the eastern Pacific, okay, eastern Pacific Ocean, that is eastern southern Pacific Ocean, and we find high pressure over the eastern tropical Indian Ocean. So these change, okay, this periodic change in the pressure condition is known as southern oscillation. And here the difference in pressure over Tahiti, that is Pacific Ocean, 18 degrees south, 149 degree west, and Darwin in northern Australia, that is Indian Ocean, that is 12 degree 30 minutes south and 131 degree east, is computed to predict the intensity of the monsoon. And if the pressure differences are negative, it would mean below average and a late monsoon. That means difference in pressure over Tahiti and Darwin is computed to predict the intensity of the monsoon. And if the pressure difference is negative, then it means below average and a late monsoon. Okay, see here, here we have Darwin, and here we have Tahiti, an island. Okay, so what we have to do is we have to compare the pressure value over Tahiti and over Darwin. Okay, we have to compare the pressure value here, means a difference in the pressure values. So here pressure anomaly over Darwin means differences in pressure over Darwin to be compared with the pressure differences over Tahiti. And if pressure over Tahiti is lower, okay, if the pressure over here, if the pressure over Tahiti is lower than the pressure over Darwin, the southern oscillation index is negative. It means that Indian monsoon will be late. Okay, if pressure over Tahiti is lower than the pressure over Darwin, okay, the Indian monsoon will be late. So that is the point mentioned here. See here, if pressure differences were negative, okay, it would mean below average and a late monsoon. So in this way, difference in pressure over Tahiti and Darwin in northern Australia is computed to predict the intensity of the monsoon. If the southern oscillation index is negative, then Indian monsoon will be late, as given here. Okay, we have to find out the pressure difference over Darwin, that is pressure anomaly, and the pressure difference over Tahiti. We have to compare the values here and the values here. And if the value is negative, that means Indian monsoon will be late. In other words, if the pressure over Tahiti is lower, and if you find higher pressure over Darwin, that means the southern oscillation index is negative and the Indian monsoon will be late. Any question from your side, boys and girls? Okay, so let us continue. A feature connected with southern oscillation is the El Nino phenomenon. Okay, What do you mean by El Nino? El Nino means a phenomenon in which a warm ocean current that flows past the Peruvian coast in place of cold Peruvian current every 2 to 5 years. The changes in the pressure conditions are connected to El Nino, and hence the phenomenon is referred to as the ENSO event, that is El Nino Southern Oscillation. Now let us see. Okay, see here. See. So under the normal condition, see here we have Peru. Okay, so west of Peru we find cold waters. Okay, here you will find a cold Peruvian current under normal condition, and because of this cold water we find high pressure over the eastern southern Pacific Ocean, and we find low pressure over the eastern tropical Indian Ocean. Okay, so this is under the normal condition. And so in certain years, instead of this cold current here, you will find warm current. As you see in this diagram, there was cold Peruvian current. Okay, there was cold Peruvian current, and instead of this cold Peruvian current, it is replaced by warm current. And because of this warm current, okay, low pressure is developed here. And here again, here in the tropical eastern Indian Ocean, we find high pressure. So this condition is known as El Nino. So there was cold waters here, there was cold Peruvian current. Okay, but due to certain conditions, atmospheric condition, instead of cold current we find warm current here, and this condition is known as El Nino. Okay, the replacement of the cold Peruvian current by a warm current is known as El Nino, and because of this replacement the pressure condition is also changed. There was cold waters here, because of that we find high pressure, but when we find warm waters we find low pressure here, and reverse is the case here. Again here we find this higher pressure when we have El Nino, and this combined effect of this El Nino and this pressure condition is known as El Nino Southern Oscillation. See here, the changes in the pressure conditions are connected to the El Nino. That means when there is cold water, there is high pressure, and when there is warm water, there is low pressure. That is the point mentioned here. The changes in the pressure conditions are connected to the El Nino, and hence the phenomenon is referred to as ENSO event, that is El Nino Southern Oscillation. The combined effect of the El Nino and the Southern Oscillation is known as ENSO, El Nino Southern Oscillation. And last of all, here you have to know is that El Nino is a Spanish word meaning docile and refers to baby Chris. That means the literal meaning of El Nino is baby Chris. And why the name is given? Because see, when we celebrate Christmas, this flowing of warm water is started, hence the name is given. Okay, when the warm water is start flowing, okay, so we at that time, so we celebrate Christmas. In other words, when we celebrate Christmas, okay, so the warm water is start flowing in certain years, and hence the name is given. You know that So we celebrate Christmas during the winter season. But you must know that when we have a winter in the northern hemisphere, okay, they have the summer in the southern hemisphere. That means when we celebrate Christmas, okay, in winter, they are celebrating in summer. And at this time, these cool ocean currents here west of South America is replaced by warm current in certain years, not every year, okay. It may be say for every 2 to 5 years, and this is known as El Nino. Do you have any question from your side? Why are you sending unnecessary messages to each other? Any question from your side? If you don't have any question, then let us stop here for today. As usual, please send your names in the WhatsApp group for attendance. Thank you very much for joining my class.
Thank you, sir.
My pleasure.